Okay, now we're going to look at basically solving other types of equations. So far we've been focused on just strictly quadratic. And what we mean by quadratic is that the highest power, they all have at least an x squared in there and no higher than x squared. So we're going to look at some that have higher than x squared and then some other things that might look um, different. Okay, so solving, these are going to be higher ordered polynomials. We're going to look right there. And but what they mean by order is the exponent, so higher powered polynomials. So we're going to go beyond just powers of two, okay? And to solve these, your first line of defense is always factoring. So if it's factorable, great. And so that's what we're going to do here is we're going to set the equation equal to 0 and list the terms from highest to lowest power if needed. First one's ready to go. Then we're going to factor out a GCF if possible. Okay, and then factor what remains after that. Now note, if the polynomial has four terms, you should probably be thinking about factor by grouping, okay? And that's always true. Whenever there's four terms, you always want to think factor by grouping. Might not always work, but that's always should be your first thought. And then once it's factored, then you use the zero factor property to go ahead and solve it. So looking at our first one, we can see that, okay, between these two terms, I can factor out a 3 and I can factor out x squared. So we'll go ahead and do that. So that will leave me with x squared minus 16. And you can always test it. If you were to redistribute, you go right back to where you were. But we want to continue factoring. So the name of the game is really to get these exponents into ones, right? Well, what I can do right here is that x squared, that's the same thing as x times x. So I can actually go ahead and write that as x times x, and now those are powers of 1, okay? And then here I actually have the difference of two squares, okay? So right there, I'll go ahead and write this down. So x squared minus 4 squared. So see, I have the difference of two values that are squared. And so there's a pattern for that. And so what we can do here is we write that as x plus 4, x minus 4. Okay, and you can always check that if you want to. If you FOIL that together, it would go right back up to what we had right here. Okay, so now we have all the variables with powers of 1. Okay, and so now we're trying to figure out, okay, what makes this equal 0? Well, all of these things right here are getting multiplied together. So if any one of them is 0, it'll cause the whole thing to equal 0, right? And so you have x right here. So if you were to let x equal 0, that would cause this to go to 0. It would cause the whole thing. It's a domino effect. It would cause the whole thing to equal 0. So that's one of your answers. And you might be like, well, there's another x. I guess x equals 0 again. That is true, but we only write it once. Okay, so we don't want to write it a second time. That's multiplicity of 2, and we'll talk about that in a later unit. Okay, looking at this solution right here, I'm assuming most of y'all are going to do this in your head at this point, so I'm not going to take the time to set them all equal to 0 and solve. So this one right here would be x equals negative 4, right? If you plug in negative 4 plus 4 is 0. Then this one right here would be positive 4, right? And then when you're doing your homework or your exam, you're going to put them in set notation. Doesn't really matter the order you put them in, just list all three of them and you'll put them in these little brackets. They should already be there on the homework. All right, let's try a couple more of these. Okay, so if we look at number 3 right here, let's see. Well, I need to clean it up a little bit. So I'm going to set this equal to 0. So I'm going to go ahead and move everything to the left side. So I'm going to subtract 12x from both sides. I'm also going to subtract 8. Okay, so on the right side, all that stuff just is nullified. It's canceled out. On the right side, we'll put this in highest to lowest power. So we'll start with 3x cubed, then plus 2x squared, minus 12x, and then minus 8 equals 0. Okay, so up above on the directions on how to approach these, if you have four terms, you should be thinking factor by grouping. So we'll group the first set and the second set. On the first set, it looks like I can pull out x squared, and that will leave me with 3x plus 2. So that kind of helps me on my second set because I need the same thing. I need a 3x plus 2. So I need to factor something out that will make that happen. And it looks like that'll be a negative 4. So I'm going to put minus 4. And so that would turn this to a positive 3x. And that would turn that to a plus 2. And once again, you can kind of see if it were multiplied back in, you'd go back to the previous step. But we want to go ahead and finish this. So we're going to go ahead and factor out that common factor of 3x plus 2. And then my other factor is x squared minus 4. And so what you'll notice here is I have the difference of 2 squares again. Okay, so I have the difference of 2 squares. So I still have the 3x plus 2. And then this will factor into x plus 2, x minus 2. So once again, we have 3 answers for this one. So the first one will be, let's see, if you were to take this and set it equal to 0, you would get negative 2/3. Set this equal to 0, you get negative 2, and then positive 2. Once again, the order that you list them doesn't actually make a difference, so don't worry too much about that. Okay, so looking at 7, looks like we have a similar example here. Things are a little out of sorts, though. So once again, I'll move everything to the left side. So I'm going to subtract y from both sides and add 8y squared. Okay, so all that cancels out on the right. Now on the left, I want to make sure and put this in the right order. So you can kind of think of all this stuff just kind of floating around. And so we'll grab the 4x cubed. I'm sorry, y cubed. Then let's see, then we'll go next. It's going to be the 8y squared, and that's positive. Then minus y, and then minus 2. So we kind of cleaned it up and put it in the right order. And now we do our factor by grouping again. So on the first set, let's see, we're going to pull out a 4y squared. And that'll leave us with y plus 2. Well, that's weird. I got minus y minus 2. So what I'm going to have to do is pull out a negative 1. So I pull out a negative 1, and that will give me positive y plus 2. So it causes a sign change. And that's what I wanted to do. So now I have those matching factors. So now we'll go ahead and factor out the y plus 2. And then my other factors can be 4y squared minus 1. Now this problem is really not any different than the one we just got done doing over here. It's just that the difference of 2 squareds is a little bit more, it's got a little bit more to it. Okay, so I'll actually take a little extra step here to show that. So what I'm going to do here is this first term, I can rewrite it as 2y squared. And then 1, I can just write 1 as squared. 1 squared is still 1. And so now I just wanted to make sure we see that, yeah, we do have the difference of 2 squares. It's just a little bit more challenging. Not that big of a deal. We did some examples similar to that in some previous sections. Okay, so now we'll go ahead and break that apart into 2y plus 1 and 2y minus 1. All right, so then let's see, we'll set each one of those equal to 0 and solve. So the first one will give us negative 2, second one will give us negative 1/2, and then the third one would give us a positive 1/2. Okay, so a lot of this was familiar. It was factoring and stuff, so hopefully that was not too bad. What we're going to look at next will be a little different. We're going to look at solving radical equations. So those are our square root equations. And so up here, this is kind of the steps for solving these. So right here it says, if necessary, arrange terms so that one radical is isolated to one side of the equation. Fortunately, we're only going to deal with one, so that shouldn't be too bad. Uh, Step 2 says raise both sides of the equation to the nth power to eliminate the nth root. So we're going to be dealing only with square roots, but sometimes you could have like cube roots or fourth roots or whatever, and so you'd raise both sides to whatever that root is. For what we're going to deal with, we're just going to look at square roots today. Then once you do that, you go ahead and solve your equation. It should be fairly simple. We have all the tools for that. But the last thing is you do want to check the proposed solutions because sometimes they don't always work. Because whenever you square both sides, there could be unintended consequences that occur. So you just want to make sure and check that your answers are correct. So on these, sometimes you get one answer, sometimes you actually get two answers. Sometimes they work, sometimes they don't work, sometimes only one works and the other doesn't. So you just have to check them. Okay, so looking at our first one here, we'll go ahead and isolate the radical. So I'm going to have to add 4 to both sides to get started. So we're going to have the square root of y plus 7 equals 8. And then what we're going to do to nullify the square root is we're going to square both sides. So it nullifies the radical, and I'm left with y plus 7 equals 64. Then I'll subtract 7 from both sides. And so I get y equals 57, it looks like. Okay, so that looks good, but we want to go ahead and check it real quick. So we're going to check. So we're going to let y equal 57 and make sure the math works out. So the square root of 57 plus 7, take away 4. Does that equal 4? So we're kind of asking ourselves this question. So we're going to verify. So this right here will become the square root of 64 minus 4. Square root of 64 is 8. 8 minus 4 is 4. So you can see that we're good. It checks out. So that answer works. All right, let's look at another one of these. Okay. So number 7 here. So looks like my radical is already isolated, so I'm good to go. So we'll go ahead and square both sides. And so that's going to give me x plus 2 equals negative 4 to the second power becomes positive 16. So negative times a negative is positive. Then let's see, we'll subtract 2 from both sides. So we get x equals 14. Okay. Now we'll go ahead and check that. We'll go ahead and let x equal 14 and see what happens. So let's see, square root of 14 plus 2, does that equal negative 4? Does that equal negative 4? Well, let's see, square root of 16 is 4. 4 does not equal negative 4. So that is going to be false. False. So the answer that we came up with actually does not work. And so we're going to say no solution. And when you're doing your homework, that will be one of your options for every question, is to put no solution. Okay, so we're going to try a couple more of these. They'll get a little bit more interesting. So let's see. Here on number 11, once again, we're isolated, so we can go ahead and square both sides. We're ready to go. So let's see, the radical will get eliminated, so we'll have 3x plus 18. Let's see, equals x squared. Now, we want to set this equal to 0. A lot of times students will be like, oh, well, I'll subtract both sides by x squared. You can do that, but I prefer to try to keep this positive. Okay, so what I'm actually going to do is I'm going to subtract 3x and 18 to both sides so I can keep that leading coefficient positive. There's other ways I could do this even if I moved it over, but anyways, that's the way I'm going to do this one. So 0 equals x squared minus 3x minus 18. So, by the way, you know, what's different about this is we do have x squared, right? And that's why I set it equal to 0. Put all the terms on one side. because you should think factoring. I should probably be able to factor this, and that is going to be the case. We can go ahead and factor this by doing our A&M method, right? So let's see, what multiplies to give me negative 18, but adds to give me negative 3, and that should be a minus 6 and a plus 3. Those multiply to give you negative 18. They add to give you negative 3 in the middle. So our proposed solutions are going to be positive 6 and negative 3. Those are the solutions to this equation here. Now, I squared both sides in the beginning, and so there can be some unintended consequences. So maybe they both work, maybe they both don't work, or typically only one works. And so that's probably going to be the case, is that one works and one doesn't work. And the only way we're going to know is by checking them. So we'll bring this over here. So we'll start with 6. We'll let x equal 6. So we're going to the square root of 3 times 6 plus 18 equals 6. So see, I'm just plugging in 6 in both spots where x appears. And then now we're just checking it. So let's see, we'll get the square root of 18 plus 18, which is the square root of 36, which is 6. So everything checked out. Now we'll try negative 3. What if x equals negative 3? So we'll have the square root of 3 times negative 3 plus 18. Does that equal negative 3? So once again, this is a question. We'll go ahead and see if it's true or false. So let's see, we're going to get negative 9 plus 18, which then gives us the square root of 9, which is 3, which does not equal negative 3. That's going to be false. That's false. So when you put your answers in, you do not want to include negative 3. We only want to include 6, okay? Or else it will be counted wrong. So one of the patterns you're probably picking up on, and this is true, is that when you take the square root of a number, your answer always has to be larger than or equal to 0. Your answer is always going to be positive or 0, right? And so whenever you have a square root equaling a negative number, right away you'll know that that's impossible. You can't take the square root and have it equal negative 3, okay? So just something you might want to keep in mind here. All right. Moving on. Right here, more of the same. We've got the radical isolated, so I'm going to square both sides. So we square them. And so when you do that, this will give us x plus 3 equals. Now, when you're looking here, you can break it apart. You get right here, x minus 3 squared. What that really is that's, x minus 3 times x minus 3, okay? And so be careful. The most common mistake students will make is they think it's x squared minus 3 squared. You can't distribute that right there. That's not what's taking place. So x minus 3 squared, you break it apart and you can FOIL it. So x times x is x squared, then minus 3x, then minus another 3x, and then negative 3 times negative 3, that's a plus 9. And then you do have those like terms in the middle, so we'll clean this up a little bit. So it'll give us minus 6x in the middle. Okay. Now we'll go ahead and set this equal to 0 and factor it just like the previous one. So we'll subtract an x from both sides, and we'll subtract 3 from both sides. That cancels out. 0 equals x squared minus 7x plus 6. And then this factors right here. Let's see, so doing the A&M method, that should be minus 6 minus 1. And so your two proposed solutions are positive 6 and positive 1. Okay, so now we have to go and check them. So we'll start with 6. So let's see, we have the square root of 6 plus 3. Is that equal to 6 minus 3? Okay, so we'll go ahead and simplify each side. So on the left side, we'll get square root of 9 equals 6 minus 3 is 3. And right there, you know it's true, so you can just stop. So that's true. So we know that 6 works. Okay. Now, like I said, a lot of times one works and the other one doesn't work, but that's not always the case. So we'll be careful and make sure we check each one. So x equals 1. So let's see where I have the square root of 1 plus 3 equals 1 minus 3. So we're going to get the square root of 4 equals negative 2. Nope. False. And so what we'll want to do is make sure we don't include that as part of our solution set. So I guess we got the same answer again, so just 6. All right, so I have 2 more examples of this first to get some practice. 15 is really not much different from the one we just did. So we'll start by squaring both sides. Okay, so we're going to get 2x plus 13 equals, and so remember, break this into 2 binomials and FOIL it, okay? So x times x is x squared, then plus 7x, and then plus 49. And you do have like terms in the middle. So let's see, let's clean this up. All right, so now we'll set that equal to 0. I'm going to subtract 2x from both sides. And I'm going to subtract 13 from both sides. So the left side, everything cancels out. All right, so now we're ready to factor this. A&M, right? So let's see, it looks like multiply to give us 36, but add to 12. I believe they're both going to be x plus 6, right? So we get the same solution for both of these. So the only proposed solution we have is a negative 6. Okay, so we will go ahead and try that and see if it works. So x equals negative 6. Let's see if that works. So the square root of 2 times negative 6 plus 13, does that equal negative 6 plus 7? So once again, just plugging it in where x appears. So on the left side, let's see, we'll have negative 12 plus 13 equals 1. And then that'll give us the square root of 1 equals 1. That is true. So we're good to go. So my answer is negative 6. So be careful. Sometimes you test this and you get down to, 1 equals 1. You're like, oh, the answer is 1. Well, be careful. Yes, the equation became balanced. The two sides were balanced, but the actual answer is what we plugged in. So something I should probably mention. So be careful about that. All right, last one. Okay, the only difference on this, and I guess we haven't really dealt with this until now, is that the radical is not isolated. So the radical, that minus 8 is not part of it. So before I can square both sides, I actually need to go ahead and add 8 to both sides. So we'll go ahead and do that. So now I've isolated my radical. And now I'm ready to square both sides. So square the left, square the right. So here, once again, you might be picking up on the pattern that's occurring here with these. But I'm going to go ahead and rewrite it and FOIL it. So x times x is x squared. And then I'm going to get 8x and 8x. That's the pattern I'm talking about. So you're going to get 8x and 8x. So really it's going to be 16x. And then 8 times 8 is 64. So I kind of skipped a step there. I knew I was going to have like terms. So I just kind of went ahead and did that all at once. Okay. And then we'll go ahead and set this equal to 0. So that cancels. 0 equals x squared plus 14x. And then plus, let's see, what is that, 45? There we go. All right. So we'll go ahead and factor that. So let's see, multiplies to give us 45, add to give us 14. Let's see, what are we looking at? 5 and 9. That looks good to me. 5 and 9. Doesn't matter which one goes first. So plus 5, plus 9. So that multiplies to give you 45, adds up to 14. So our post solutions are -5 and -9. Once again, probably only one of them works. So we're going to go ahead and check it. So x equals -5. Let's see. So let's see, the square root of 2 times -5 plus 19. Take away 8. Does that equal -5? You might be thinking, how is it going to equal a negative? Well, you have that -8 right there, so it's possible that it could equal -5. So we'll go ahead and finish this out and check it. So the radical, let's see right here, that'll become -10 plus 19. Take away 8. Does that equal -5? And then let's see, this will become the square root of 9 minus 8, which will become 3 minus 8, which is -5. So it did equal -5. And it so happens that the answer actually is -5. So that was just kind of a little coincidence. Okay, so -5 is good to go. All right, so now we need to go ahead and try -9. So x equals -9. So if I plug that in, let's see what we'll have here. We'll have the square root of 2 times -9 plus 19. Then we're going to take away 8. And then we want to see, is that equal to -9? So we'll put a little question mark there. So that's what we're trying to check. We're plugging in -9 for x in both of those. And then I'll scroll down for more space. All right, so just got to do some algebra to check this. So let's see, square root of -18 plus 19, take away 8. This will become the square root of 1 minus 8. So then 1 take away 8 is -7. -7 does not equal -9, so that is false. And so we want to go ahead and not include -9 as part of our solution set. So this particular book, a lot of where we're getting these examples, a lot of the examples only one solution works. Sometimes, neither work or whatever. But it is possible that they both work. But apparently this book doesn't have any examples of that. So anyways, if you have any questions or concerns, feel free to reach out.